This example is much trickier than the other two that I just did. The reason? Exponents. So what we have to do here is basically the FOIL method. We need to get rid of these exponents before we can combine anything. So first we need to multiply through. So it's the same as x plus 3 times x plus 3 minus xy plus x, xy plus x, plus yx, y plus x, y plus x minus y squared. So there's actually a few tricks that you can use on multiplying out exponents. The first one, which I will do for here, is you know it's going to be x squared because x times x. So it's the first term squared. You know the last term is going to be 9 because it's the last term squared, 3 squared. The middle term, you can use a shortcut here by going 2 times x3, which works because otherwise you're going to go x times 3 plus x times 3. So there's 2x plus 3's. And we'll do it again for this next term. So on this one, we're going to have to square our first term, which is there, because xy all squared plus 2 first term times last term, xy x squaring the last term plus x squared. And that works because, just like the last one, x squared, or xy times xy will be xy squared. Xy times x and xy times x would be 2xy times x. And to finish it off, x times x would be x squared. There's also a trick for multiplying out cubes, and it was much easier to multiply out the cube using the trick than it would be to multiply first as a quadratic and then multiplying the quadratic by a few extra terms. So what I'm going to show you guys is what you do is first you take your first term and cube it, just like we did for the quadratics. Then take your last term and also cube it. Okay? And this, now you need to know that you're going to go down in power of the y's and go up in power of the x's. So that's y squared x plus yx squared. But you're missing one thing here, which are the coefficients. Just like how we had a coefficient of a 2 and a coefficient of a 2, these ones are going to be coefficients of 3's. And I'll draw out a picture just in a moment, just so you can understand where that comes from. And then we just have r minus y squared. So I'm just going to rewrite this so it's a little cleaner. X squared plus 6x plus 9 minus xy all squared plus 2x squared y plus x squared plus y cubed plus 3y squared x plus 3x squared y plus x cubed minus y squared. And what I meant by where the coefficients come from, an easy way to remember is using the Pascal's triangle. So everybody knows what a triangle looks like. Now if we start putting a 1, a 1, and a 1, and then we add the two ones together, we get a 2. Sorry. And now bring the ones down on the outside. If we add the 1 and the 2, we get a 3. And you can keep going for as far as you need to go. 1 and 3, 3 and 3, 3 and 1 would be 4, 6, 4. And this triangle continues all the way down until as far as you need to go. And what it does is it shows you that for multiplying out a quadratic, the terms are going to be 1, 2, 1, as we've seen up above. And if we wanted to multiply out a cube, it would be 1, 3, 3, 1. And if we wanted to multiply out something to the power of 4, as long as it's only a binomial, so there's the two terms, which goes with all of them, which goes for all of them, then 1, 4, 6, 4, 1. And you can just continue in this pattern going all the way down. But getting back to our problem, so now we have to look at what terms we have. So if we look at any x squareds, only x squareds, we have one there and one there. So let's combine them. X squared minus x squared. And now we look at the next terms. Let's look at our individual x's. We have a 6x. We have no individual x's in the next term, none in the third, none in the fourth. So now let's look at our single digits, which we only have a 9. Now let's look at our x squareds, y squareds. So which is minus x, y, all squared. We do not have any more of those either. I'm going to have to start doubling up on colors, so keep in mind. Now let's look at our x squared y, which we do have another one over here. So that is going to be 2x squared y plus 3x squared y Our next terms are going to be a y squared x, which we only have one of them, and same for the y cubed, we only have one of those. So plus y cubed plus 3y squared x. Oh, I made a mistake on something. Remember to carry through that negative. I did not carry it through, so note right there. And now we just have the last few terms, which is a plus x cubed and a minus y squared. Okay, and now let's keep combining these. Okay, so now we have basically 1x squared minus 1x squared. The x squareds are gone. So we're left with 6x plus 9 minus xy all squared plus x squared y, because 3 minus 2 is 1, plus y cubed plus 3y squared x plus x cubed minus y squared. Now it's best to group them into descending order like we did previously, but since now there are y cubes and x cubes, try to put the x cubes on the left and the y cubes on the right and try to go from there. No, it will not be perfect, but at least it will be something. So x cubed minus x squared y squared, which is from there, plus x squared y. And I like to personally cross them out as I go, just so I don't end up rewriting the same term a few times. And now we have plus 6x. Now I will go with plus 9. Minus y squared plus 3y squared x plus y cubed. And that will be your final answer.